So let's start by taking the expected value of n. Well, first of all, what do you think the expected value of n would be as a result of this distribution? Just don't look at it. I'm sort of trying to figure out your intuition. Now, again, we have a distribution where everybody is going to order the same day, but that day is going to be randomly selected. So if you think about the expected number of orders that will be given in a given day, it will be the same as before. And we can see it from the distribution. You can see that we are going to have 1 minus 1 divided by r times 0, plus 1 divided by r times n, and this is going to be still n divided by r. In other words, we are note that none of these schemes are going to change the expected value of n, which is very reasonable. However, the variance of n is going to change. Now, what will be the variance in this case? How are we going to compute the variance? In order to compute the variance, actually, what we're going to do is, this is a discrete distribution, okay? And how do we compute the variance? You take the square of this value multiplied with the probability, square of this value multiplied with the probability. So in this case, the variance of n, well,
it will be the x squared.
Okay, and then we're going to have the x squared. Okay, and then we're going to have this one minus, actually. So if you do that, this is going to be n squared divided by r, or let me write it this way, excuse me, n squared, and then we will have 1 over r, 1 over 1 minus r. Okay. Now, so now we have exactly the same thing. So we're going to go using the same order as we did before. So I could easily keep this on the board, but I will rewrite it again. So now we are going to have, of course, a different z random variable defined. This is going to correspond to the case where we have, so we are going to have z sub t. Now this time we are going to have correlated, COR, which is the same thing, but this time under this scheme. So this z, and again, I am going to compute the variance of zt correlated. Note that the variance is again going to be computed using the formula that we had before. It will be the same thing. So let me write what we are going to see. So this is basically expected value of the variance of zt correlated given n plus the variance of the expected value zt correlated given n. So term by term. Now I am going to write this one. This is going to be expected value of n r sigma square plus the variance of n r m. And so in this case, this is going to be n sigma square, and the remaining is going to be m square, r square, and now we have variance of n, which is n squared divided by r, 1 minus 1 divided by r. So by doing similar operations, canceling these r's, we're going to have m square, n square times r minus 1. Okay. So again, when r is equal to 1, in other words, if we know that we have a review period 1, then what becomes as positive correlation is no use now, because we have, if R is equal to 1, then everybody is going to order in the same day, and we know that. So it will be exactly the same case when we had R is equal to 1 of the previous case. Okay, it doesn't matter whether it is random or not, because you have only one day that you can order. So in that case, there is no bullwhip effect. Otherwise, the bullwhip effect is going to be with m square, n square, r minus 1. Now, what can you say about the bullwhip effects compared? You see that here we have a term capital N square, whereas we had capital N in the random case. So you can see that, okay, with respect to the bullwhip effect, if we ask the retailers to select their ordering days randomly, rather than ordering at the same time, all ordering at the same time, we're going to decrease the burden on the supplier. However, of course, we know that the retailers are ordering this way because they have some kind of a logic, because they usually are ordering before the high demand period. Okay? So note that here you immediately see that there is a possibility of coming into an agreement, because action of the retailers is hurting the supplier, but on the other hand, any other action is going to hurt the retailer, so there should be a middle way which is going to make everybody happy. But here it's not going to be our topic. We are only interested in the bullwhip effect. Okay, any questions on this? Yes? English, of course, yeah.
If they give the order in the same day, then there will be more bullwhip effect.
Of course, this is what it is saying. In other words, if they give their orders in a correlated way at the same day, okay, you see the way that the supplier is going to observe the demand will be as follows. So let's say that these are days. So you have day 1, day 2, day 3, day R. Okay? How the supplier is going to see the demand is, of course, in the following way. Zero demand, then you have a huge demand, zero demand, zero demand, zero demand. This is going to be the way that they are going to see. And of course, this might change in the next week, because that's the way that we selected. So a huge demand may come anytime. Okay, so then the variance that the supplier sees is going to be pretty high. This is the reason. Whenever, in the previous case, when it was sort of random, it was much better, because at least you had some chances of being somehow balanced. But it's random again, so it means that it can be really bad as well. Okay, so the third case that we're going to analyze will be, of course, the case where we are going to have more control. Okay, so and that will be the case we're hoping to have less bullwhip effect. Okay, now the third one is going to be called balanced. Now first I'm going to explain what's going to happen, and then we will discuss the results. Now, one thing, you can see at this point that if we can make sure that the supplier receives equal orders every day, even if it doesn't observe the demand of each retailer day by day, okay, the bullwhip effect is going to be minimized. In other words, if we can create this balance throughout the week. So the balance scheme is actually going to do that. So let Ant and R be related, these are integers, be related to each other by two additional integers, K and L, in such a way that we can write N is equal to L times R plus K. So this is like the modulo operation, okay? You take everything in terms of modulo of R, okay, sort of. So, for example, let's say that N is 35 and R is equal to 4. So it means that L is going to be 8 and K is going to be 3. What's the meaning of this? It means that if we have 35 retailers and R is equal to 4, capital R, sorry, then it means that each day we are expecting to have 8 of them ordering, 8 of the retailers, and there will be 3 additional days where we will have the 9th coming into picture. Now, in balance, what do we want to do? These are identical, they all have identical demands, don't forget that. So we want these numbers to be balanced. So what do? Is very simple. As a supplier, you say that, hey, retailer number 1, retailer number 5, retailer number 9, you order on Monday, you order in day 1, and then you take the other 9 retailers, you say that you order in day 2, you give them no permission of changing the way that they order. Okay? So this is actually what we mean by balanced. Of course, when you have K is equal to 0, it means that you have perfect division. It means that you can divide total number of retailers into days equally. So this is what we really want. Now, if you do the same thing, so we have this time, we are going to have variance of Z sub t balanced in that case. Now, of course, we still have the random selection of the day. In other words, each of them can do this in any given day, so we are not restricting that. So if we do this, then the ZT balanced is going to have n times sigma square, which is again the same part. And then we're going to have m square times k r minus k. Of course, you see that if we can create perfect division, the bullwhip effect will disappear. And if it is not perfect, this is, compared to the others, will be a very small number. So you can see that the ordering is going to be variance of the ZT correlated is larger than the variance of Z sub t random, and it is larger than or equal to variance of Z sub t balanced. Even in the balanced case, because of the numbers, you might have some bullwhip effect. So even in the perfect case, you might have some bullwhip effect. Of course, in reality, if you add lead time, if you add forecasting, which are present there, you are going to have more bullwhip effect, and this is going to be an additional term affecting your bullwhip. Now, this is a very interesting result, because in practice, sometimes people take some actions which are going to be against this understanding. Very simple example. Firms give to their marketing people, they give some bonuses with respect to the total sales that they make in certain periods. So, for example, what does this mean? It's usually monthly. Automobile dealers, for example, they receive a monthly bonus over if they exceed a certain limit at that month, or for the total amount of sales that they do in that month. Okay? Depending on the firm, the rule is different. So the way that they define the month is very simple. They take end of the month. They say that if at the end of the month I'm going to check your records and I'm going to pay you accordingly. Okay? Very, very straightforward. Now what happens is that, of course, when time is getting closer to the end of the month, these salespeople are going to work more, and they will make more sales. That's the reason why if you look at the records, automobile sales towards the end of the month is always larger than automobile sales in the beginning of the month. There is no reason for that. I can understand that at the end of the year, there is a reason, because basically it is the tax period. So people adjust their expenses in terms of the tax that they are going to pay. So automobile sales increase at the end of the year because they are going to show it as an expense. But for the automobile sales to increase during the towards the end of the month has no serious logic, even if, okay, most of the people are paid on the 15th. Okay, because that payment is small probably for automobiles. That it's not very meaningful. So question here is, if you are manufacturing this automobile, you are going to receive increased demands towards the end of the year from the retailers, and then there will be actually no sales in the beginning periods. So this is not good for the manufacturer because of the bullwhip effect that we are seeing. It's almost biased. Almost all the car dealers are going to order automobiles so that they receive a lot of automobiles on the 20th of a certain month, so that they are going to sell at the end of the month. Okay, so this is something that we create within the firm. Now, a suggestion would be very straightforward, which is going to remedy this problem. Change the definition of time for different sales groups in such a way that they are going to be very balanced when you look at a certain month. For example, you can say that, let's say that each of you represent a group of car dealers, more or less with the same annual demand. Okay? So what I'm going to do is I'm going to say that your month of bonus starts with the 7th of a month, ends on the 7th of the next month. Your month, which I'm going to count your bonuses, will start on the 14th and end on the 14th. And I'm going to do it for everybody here. So what will this result will be simply the demand is going to be more balanced during the period, and you will be losing the bullwhip effect. As simple as that. It turns out that this very simple observation helped a lot of people. Actually, I remember talking to a lot of people, sales representatives and so on. It's not very easy to make that change, but they understand that the savings that they are going to have from the manufacturing side is going to be enormous. Note that you can also do your distribution planning in a more balanced way. This is going to help a lot. Of course, you cannot always do this because there are some certain natural limitations to that. But still, I think this seems to be more reasonable than letting everybody use end of the month as some kind of a barrier in a way. Okay, so that flexibility comes from simply this result that we see here. You can see the benefits that you are going to obtain. Any questions on this? Okay. Now I think this is the extent that I want to talk about information distortion or value of information. You can see that actually you can increase these numbers. There are numerous number of models in over there where they try to compute the bullwhip effect. Nevertheless, bullwhip effect is useful to understand certain concepts as I was describing, but we don't have any costing associated with bullwhip effect in this form. You see, it's only something that that we can use to describe certain phenomena, which is understandable up to a certain extent, but there is no cost factor, and we always have the cost side. So, for example, we understand that this is going to give us the least bullwhip effect, but it might be very costly to operate like this. So there is always a trade-off. So the way that we approach to problems in general is we try to minimize the cost or maximize the profit. On the other hand, bullwhip effect, the way that we measure bullwhip effect is not necessarily going to correspond to some monetary value in a very straightforward fashion. It will be very difficult to do this. Okay. Any questions on information distortion in general? Okay. Now I think it's time to talk about another topic, which I will call distribution planning. And we already have talked about this when we were talking about, for example, crosstalk points and so on. We talked about distribution planning, but I want to be a little bit more general now, because crosstalking is also a part of your distribution structure, network structure. So this time I am going to talk about the transportation issues in supply chain. So what I have is I used part of Chopra and Mendel, which is in your reading list, actually. So I'm going to make a presentation using the chapter of Chopra and Mendel to initiate. And on Thursday, we're going to discuss the paper by Jaikumar, which is, for one reason or another, it's one of the papers that I really like. Is it? Okay. So usually there are a lot of things in that chapter. I condensed it quite a lot, actually. We have 8-9 slides only, which I will talk about certain issues, and hopefully we're going to see a couple of them we already have seen some of them, actually, but we're going to see some of them later on. So, okay, so this is chapter 13 of the third edition. You might have the old version in your references as well, but this is chapter 13. Now, the issue is that when you are talking about distribution planning, so what we have now is we are in a situation where we have the items available somewhere, and we are going to, in order to meet the customer demand, we are going to ship those to different locations. Now, the network structure is important, whether we use a crosstalk point or whether we have a warehouse, but at the same time, we also have the important transportation decisions coming into picture. Now, transportation decisions, in order to understand that, we have a number of definitions. One of them is the carrier. Now, carrier is the party that moves or transports the product. In other words, carriers are third parties which is going to do this service job, carrying job for us. So we may have our own fleet, or we may hire a certain carrier. Okay? So now carrier in that respect is going to be an independent entity which might be analyzed by herself, actually. So think about the following carrier, like Federal Express or DHL or Yurtici Posta, okay? Where they also carry some packages, reasonable size packages. So what is the problem for them? They have a lot of demand coming in from this node to another node. They have to carry that from this node to another node. And what happens is that we have vehicle-related costs, we have fixed operating costs, and we have trip-related costs. Now, as a carrier, I want to minimize my costs so that I will have more portion of the revenues. But in reality, I have another decision as well. I'm going to set the price. Okay? So to plan for a carrier is an issue in itself. Okay? It's a part of the supply chain. It's a very important part, but it's also a very interesting problem in itself. And like carriers usually solve vehicle routing problems. Carriers usually solve different types of routing problems, not only vehicle routing, but capacitated vehicle routing problems. They have time windows that they need to satisfy, and they also have the problem of setting their price, which is rarely dealt in that literature. So it is a rather open area, actually. if you want to consider this planning issues together with the pricing issue, it's a different ballgame. Now, who is a shipper, on the other hand? Shipper is the party that requires the movement of the product between 2 points in the supply chain. Now, usually, if I am giving an order, I am probably designated to be the shipper. But it turns out that you can have different types of agreements. For example, we all know the word FOB. FOB means that freight on board, which means that the supplier who is supplying that is going to be responsible for the shipment and the costs of that up to a certain point. Up to a certain point which is decided. And on board means that, for example, if you put everything on a ship, actually, the placement up to that ship is under the responsibility of the supplier. It comes from that word, actually, FOB. So you have different types of possibilities. For example, if you are a retailer ordering, okay, from Coca-Cola, let's say, and we are talking about Migros ordering from Coca-Cola. Now, when do you think Migros is buying the item? Actually buying the item. In other words, once the lot leaves Coca-Cola grounds, okay, bottling grounds, is it under the ownership of Migros? Or is it under the ownership of Migros at a later point? Okay, we don't know. It depends on the agreements. In the case of Coca-Cola, usually Coca-Cola owns the brand with respect to Migros until it is sold. Okay, Coca-Cola pays everything until it is sold. Whereas if you are talking about some other material, usually the retailer is going to pay the money ahead of time and then there will be a shipment. Think about Amazon.com. Okay, when do you owe the item? At the point that it leaves the headquarters of Amazon.com or the warehouse, it is yours actually. And you pay for the road, you pay for the dues and taxes and everything. Okay? So it depends on the agreement that you are going to have. So shipper is the party who is responsible and who is going to be responsible for the shipment duration. So this is the party who is going to give the transportation cost. You see, what is the transportation cost? If the carrier is doing the transportation, it is the price that the carrier is going to charge. Okay? So that becomes the cost for the shipper. And then you have the inventory cost, you have the facility cost if you pay anything and so on. If carrier does it, of course, you only have the transportation cost and the inventory cost. If you do it yourself, you are also going to have maybe facility cost. Okay? So you can see that that breakdown is going to be arbitrary depending on the situation. Who owns the item and who is going to pay for the shipment. So you can see the distinction now. So in that respect, the person who is doing the analysis becomes very important. The entity, I mean. So for example, if you are analyzing from Migros' point of view, transportation cost of the Coca-Cola is irrelevant for you. So the way that you make an agreement with Coca-Cola is on the service that you are going to get from Coca-Cola. Whereas if we're talking about Amazon.com, you are interested in the money that you pay, of course, for transportation. Because that becomes an important part of the cost. Okay, it would have been very nice if you didn't pay any of those transportation costs. So who is bearing the cost becomes very important when you are making economical decisions. Okay. Now, transportation modes, we are familiar with that. We have trucks and truckload, full truckload, or less than truckload trucks are possible. Usually less than truckload means that we are going to pay per unit, some kind of a unit is defined, and you pay per unit. Whereas if it is truckload, then you pay for the truck. But of course there is some limitations with respect to volume and weight. Rail is becoming an option in most of the Western and Eastern, Far Eastern countries actually. So rail is becoming one of the serious options. Even in Turkey, as a mode, rail mode for trade purposes is becoming a serious one. Now, for certain cases, it is inevitable. If you are, let's say, exporting a very heavy item like coal, and what you have to do is usually you carry coal to harbors, or from harbors you carry coal using rail. And this is the way that it goes. If you have been in Ereğli, for example, Ereğli Demirçelik, rails are very frequently used for carrying because we're talking about very heavy material. So they have their own rail system within the premises of Ereğli Demirçelik, iron and steel industry. This is inevitable, actually. Now, air transportation is also becoming widespread for items which are not very heavy, and it is becoming less expensive, so it is becoming affordable comparing to the times that you have with the rail. It usually takes a long time to carry something with the rail cargo, and so air cargo is actually becoming very efficient. Now, package carriers are also becoming, they take an important part in the transportation requirements of the industry. It turns out that a significant percentage, I don't remember the percentage now, but I recall that it was around 30% that people started to use these package carriers, even in industry. And they use all kinds of modes, actually, trucks, trains, but they are not usually going to use rail. Not that I remember anyone using rail, but they have their own cargo fleet, air cargo fleet, and so they do carry. Now, water and pipeline we are aware of that. Like for certain commodities, you need to use pipelines. We have very little carrying using water resources. We have seas around the country. In Europe, they use rivers actually for very efficient carrying purposes, but we don't use it that much. So these are the possibilities, of course. And the package carriers are actually important. That's the reason why I wanted to talk a little bit more about those package carriers. Companies like FedEx, UPS, USPS, I don't know that. United States Parcel Service, I don't know. That carry small packages ranging from letters to shipments for about 150 pounds, which means that we're talking about pretty large loads as well, 75 kilos. 75 kilos, then it means that you can send 20 PCs, actually. If you come to, 20 laptops, let's say. Which is quite a load if you come to think of it. So they are going to allow quite large sizes. Varan Cargo has been doing this for years in between some cities, not all the cities, but Yurtiçi Cargo is pretty large actually, if you think of it. Now these are expensive. Compared to the other way of sending, these are expensive, but sometimes it's worthwhile because they are rapid and very reliable. In other words, for example, most of these companies would have overnight services to different regions, which means that if you can give them the package that you want to be shipped up to 4 o'clock in a given day, they promise that they are going to get it to certain location before noon next day. So this is a very important reliability issue. So when you have small and time-sensitive shipments, this is what you do. Now, most of the businesses that run their business over the internet, okay, is going to prefer this type of carrying because they don't want to have any headaches with respect to the carrying possibilities. Now, Amazon doesn't have the possibility of slow delivery. Why? Because they don't want to have the headache. They know that when you have slow delivery, it's not going to be as reliable. So they simply ask you to give a certain amount of money. Of course, if you need express, you pay more money and you get it in 2 days. But standard one is like 6 days, 5 days from Europe, and maybe 10 days from the US. So these are the standards that they have. Compared to the other possibilities, they are very reliable and fast. And that's the reason why, for example, Dell, the computer manufacturer, is actually using these type of carriers to ship computers if you buy it from your website, from Dell's website. Now, it turns out that they do a lot of consolidation. These companies do a lot of consolidation. They use the idea of transfer points or a number of like intermediate transfer points. They use a lot of those because basically it turns out that they gain a lot by doing that. So and so if I go back to the previous slide, okay, this one. So they do want to optimize this part as well for themselves because they charge a certain amount of money. They try to minimize their costs. So they do a lot of tricks actually in terms of saving money. And it turns out that it is a topic in itself and it's not that simple. Now, one other thing is, of course, which is very important, is the fact that none of these companies are going to use these modes by itself. They are going to have an intermodal, so they will have different modes being used in different points in time. Remember, for example, the paper by Eskigün, one of the papers that we read in the beginning. They were using a combination of rail and trucks, and this is the most common example. Okay? But you can use many different combinations. Now, nowadays, what some companies is doing is as follows. They have a standard way of shipping certain items, let's say via trucks. But if there is an emergency order, they use these special companies like FedEx or UPS or any other company. In other words, their usual mode is trucks, but when there is an emergency, they use the other carriers, which makes a lot of sense actually. Remember, in one of the papers we had this emergency order 1, emergency order 2. Actually, that corresponds to a carrier. Emergency 2, ET2, means that you have a very fast carrier and you pay a lot of money for that. On the other hand, your regular is going to be the trucks that you own. It might be anything. So now, of course, in order to facilitate the intermodal carrying, you need to have some fixed, I'm talking about big cargoes now, not small packages. You have to have some kind of a fixed structures which can be moved either by a truck or by rail or by ships. And these are the so-called containers. If you have been in a harbor area recently, you would probably have noticed cargoes, and the size of the containers they have different sizes of containers, but they are almost standardized around the world now. So for ship cargoes, for rail cargoes, and those are the cargoes that will go back into a truck. In other words, a truck can carry that as well. So it's almost, the size is almost standard now. So what you have is, in order to facilitate this intermodal carrying, you have standard containers which are used all around the world. The containers actually move from rail stations to harbors, from harbors to truck locations, and they are moved by trucks. And they can be placed at the back of the trucks. They can be easily picked up so that you can put it in the ship, load it in the ship, unload it from the ship, load it to the rail car, unload it from the rail car. So turns out that this is basically the way that things go. And with this usage of increased usage of containers actually increase the whole thing, decrease the delays, so on and so forth. So it is very useful. One of the interesting topics, of course, is to work in an intermodal station. It's an OR problem, actually, very typical OR problem, on how to operate that intermodal area. What do we mean by intermodal? Usually it is located in an harbor where ships actually come. They load, they unload and load containers. And then you're going to have rail, where you're going to load some of the containers to the rail cars. Some of the containers are going to be loaded to the trucks. Of course, trucks unload some containers. Rail cars unload some containers. So you have this huge traffic, and it turns out that it's not an easy problem. If you come to think of it, you have a few hoists, cranes in the area, and you need to make use of that area in the best possible way, so that you are not going to delay the ships, because we're talking about huge ships waiting there, huge rail cargo trains waiting there. You don't want to make any one of them wait for long periods, because they pay huge amount of money. And so you have to operate that area in a very efficient way. So it is a real OR problem. If you look at some new publications in the last 10 years, you see that a lot of them is coming from the largest harbors around the world are in Far East Asia and Australia, because I mean that's the way that they move things. So that area, actually, you will see that there are a lot of papers related to the work done in that area. Although there are some works in Europe as well. The largest port in Europe is in Antwerp, and the second largest is in Rotterdam. So, and they have a lot of work that, or people have done a lot of work in those two areas as well. So it is an interesting topic in itself. So this is basically the intermodal. And of course, the key issue in these days is exchange of information to facilitate transfer between different transportation modes. And it turns out that that operation can be done in a better way if you can exchange the information in a better way. Because there's always an uncertainty about the load that's coming, that's over there. You see the ship, it's going to come in 4 hours, but you're not certain about the load of the ship. Okay, there are a number of issues like that. I started to work on a problem like that last summer, but it turned out to be very difficult, actually. It is very complicated. You need to have very detailed algorithms, actually, to handle certain parts of the problem, because you have scheduling problem there, and at the same time you have to have the allocation of resources problem, and at the same time you have some cost issues which should be taken into account. So it's not only to obtain a feasible schedule, but basically you have a lot of cost issues coming into picture. Okay. Now, these are also the possibilities for the distribution systems. We are already aware of that. What are the transportation options? Which one to select, on what basis? Who is going to pay for that? Who is going to make the selection? Is it really a part of my supply chain, or am I just fooling myself by dealing with this problem? You never know that, actually, because it might be external to your system. But with the ideas of supply chain, you are interested in investigating in the transportation part as well. Now, direct shipping network, we are aware of that. Direct shipping with milk runs. Did we talk about this milk runs? Did I define milk run? Milk run is a very simple idea. It comes from the actual milk runs. Now, if you recall some old Hollywood movies, or if you, because I don't think that in your childhood you had that. In my childhood I had that, actually. The houses are like this. These are the houses or apartments, and 30 years ago we had milk deliveries coming into our places. So the milkman men. Usually they were always men. Because we're talking about working at 5 o'clock in the morning. What they would do is they would deliver milk to each house. So what they would do is, it's like a vehicle routing problem. You have a tour. You have the milkman making a tour. So milk runs, the word milk runs is actually coming from that. What you do in milk runs is very simple. You do direct shipment. So this is your warehouse. And these are your retailers, but the truck is going to make stops in different retailers. So there is always a tour associated with the movement of the truck. It's called milk runs, meaning that you carry, the item that you carry in the truck is not only for a single retailer, but it is more than for more retailers. It's very simple. So you actually solve some vehicle routing type problems to find out the idealized milk runs. So this is the idea of milk run. So you might have direct shipping, but with milk runs. Okay, so that's one thing. All shipments are going to do via a central DC, or you can use, well, there is also a counterpart for this. Let's say that I have a factory here, and I'm manufacturing in just-in-time basis. So I have 3 suppliers that is going to supply me some goods, which are all going to be used for the same manufacturing. So again, the supplier may use milk runs as well. So you might have a single truck which leaves your factory, collects some item here, okay, collects more items here, collects more items here, and come back to the factory. So that you have all the parts necessary for the same production at the same time. Okay? This is also a milk run. And there are a large number of companies in Turkey operating this way, actually, like Mako, for example. Mako imports some items from Europe, different European countries. And it turns out that they use milk runs, actually. Truck first goes to Italy, then goes to Germany, then goes to Yugoslavia and comes back to Turkey, picking up parts, actually. It is pretty interesting. So you can use milk runs there, or you can tailor your network according to your own wishes. So these are the factors affecting it. And I am going to briefly talk about this later on. But there is always this risk issue that we never consider, but I will talk about that next time. Any questions? I'll see you on Thursday. We're going to talk about the paper by Jai Kumar. Jai Kumar and Rangan and Jai Kumar. Okay. Any questions? Okay, thank you.